Hello everyone, myself Anthony Usha, Assistant Professor from the Department of Aeronautical Engineering, Gojan School of Business and Technology, going to study about space engineering. Going to talk about history of aviation, atmospheric concepts in flight, understanding standard atmosphere, pressure, temperature and density altitude. These are the topics which comes under standard atmosphere unit 1. From the unit 1 syllabus, I have break down some important topics which goes below early concepts and pre-flight experiments, advancement in aviation technology, space exploration and its influence, components of the standard atmosphere, pressure, temperature and density altitude, impacts on aviation. Early history of aviation, from myth to mechanics. Humanity's dream of flight began with legends like Icarus and visionary sketches by Leonardo da Vinci. In 1783, the Montgolfier brothers soared with the first hot air balloon, and by the 1890s, Otto Lilienthal daring glider flights brought us closer to powered flight. Here I have posted some pictures that belongs to them. Birth of powered flight. Wright brothers and the first flight. In 1903, the Wright brothers made history at Kitty Hawk with the first powered, controlled and sustained flight. Their Wright flyer marked a breakthrough, a mastering control, propulsion and lift in one leap forward. Here I have enclosed the gift which is the first flight which is controlled and sustained at Kitty Hawk. The key achievements from this flight is control, propulsion and lift. Lighter than air aircraft. Lighter than aircraft that float in the air because they are filled with a gas lighter than air like helium or hydrogen, which are less dense than air. Think of graceful balloons and iconic airships like blimps drifting through the sky. Hot air balloon. These are the lightest and simplest form, relying slowly on heated air to create buoyancy. Next, airships, which is also mentioned as dirigibles and blimps. These are powered and steerable aircraft. They can be either rigid like the Hindenburg, which had a structural framework, or non-rigid like blimps. Heavier than aircraft. Heavier than aircraft rely on engines and wings to generate lift and stay aloft. From airplanes and helicopter to modern drone, these machines defy gravity through engineered flight and are those that generate lift by using aerodynamic forces or engine thrust rather than relying on buoyancy like lighter than aircraft. This means that needs a power source or wind to stay aloft. Examples include helicopter, airplane and gliders. Heavier than aircraft versus lighter than aircraft. These are the common basis of aircraft types, which is classified like lighter than aircraft and heavier than aircraft. Lighter than aircraft, also known as aerostats, that is, achieve lift through buoyancy, means that they are less dense in air, which allows the aircraft to float, and the weight is less than the air, which tends to displace and float. Aircraft that rely on dynamic lift are heavier than air. which trust the thrust to stay in the air, which achieves using gases lighter than air like helium, hydrogen and hot air. Here in heavier than, it generates by wings. The lift is generated using the wings like airfoil shape or motors moving through air. In lighter than air, some of the examples are balloons, airships and blimps. Here in heavier than, airplanes, helicopters and gliders and modern drones are considered as heavier than aircraft. Aviation milestone. Aviation through the 20th century from 1909 to 1919. In early days, the aviation pioneers from 1900s like Glenn Curtiss and Louis Blériot pushed the boundaries of flight with control innovations and daring journeys. World War I sparked rapid military aircraft advancement, while the post-war era saw the birth of commercial aviation, marked by KLM's foundation and Lindbergh's legendary solo flight across the Atlantic. World War II and post-war boom. In World War II, we used the aircraft such as Spitfire, B-17 and Me-262 shaped warfare, and innovations which are included here is radar, jet engines and navigation systems. In the golden age of commercial flight, Douglas DC-3 1935, which plays a remarkable place, and its position is very remarkable in 1930s era, and it has the key points of reliability, comfortable and long range travel. After that, the Boeing 707 1958, which takes the position, and the first commercial jet made the global air travel common. Jet age and supersonic flight. Chuck Yeager 1947 broke sound barrier Bell X-1, and Concorde brought supersonic travel to the skies for about 3.5 hours. Advancements in aircraft technology. Boeing 747. In 1969, it was the first jumbo jet for mass travel, which enables the mass air travel. It involves fly-by-wire systems, introductions of computerized flight control system, improving safety and efficiency, which even more broader, safer, computer-controlled flight. Space exploration influences. In space, the Apollo program made history with moon landings, and the reusable space shuttle program showcased the potential for human spaceflight. Space Shuttle Program 1981 to 2011. It reuses the spacecraft that contributed to scientific research and satellite deployment. 21st century innovation, fuel efficiency and green tech. Aircraft like Boeing 787 and Airbus 350 use lightweight materials and sleek aerodynamics for unmatched fuel efficiency. Electric and hybrid planes are paving the way for a cleaner, eco-friendly future. UAVs and drones serve in both military missions and everyday tasks like delivery and surveillance. Commercial space flights such as SpaceX, Blue Origin utilize the reusable rockets in space tourism. Urban air mobility. The rise of VTOLs is shaping a new era of urban air mobility, bringing the flying taxis closer to reality. Future outlook for space research. The future of flight is being reshaped by sustainable aviation that cut carbon emissions and AI driven flight systems that enhance safety and efficiency. As technology evolves, the skies are opening up even further with the expansion of commercial space travel, bringing the dream of space tourism closer to reality. Space exploration. Space exploration is the scientific investigation of outer space using astronomy, spacecraft, satellites, and space missions. Is a scientific journey beyond Earth using telescope, satellites, and mission to uncover the universe secret. Space vehicle, also referred to as spacecraft or spaceship, is a vehicle designed for space flight or specially designed missions that make these incredible voyages possible. These space vehicles can be classified into four that are space probes, space launchers, manned spacecraft, artificial satellites. Milestone in space exploration. Space exploration has begun a new era in 1957 when the USSR launched Sputnik 1, the world's first satellite. Just 4 years later, in 1961, Yuri Gagarin became the first human to journey into the space. In 1969, the world watched in awe as Apollo 11 made the first successful moon landing. Fast forward to 1998, the launch of the International Space Station marked global cooperation in space research, and in 2021, the NASA's Perseverance rover touched down on Mars, pushing the boundaries of planetary explorations. Influences of space exploration, which comes under technological advancement, economic impact, global cooperation, environmental insights, scientific discoveries, inspiration, and education. Space exploration has transformed our world in powerful ways, from satellite communication and GPS to weather forecasting. Its technologies shape daily life. It sparked spin offs like memory foam, cordless tool, and solar panels. The growing space economy, led by SpaceX and Blue Origin, and also the ISRO, creates jobs and fuel innovations. Space has uncovered exoplanets, black holes, and new insights into human biology in microgravity. Global collaboration strives aboard the ISS and in joint missions across nations. Above all, space inspires fueling education, STEM careers, and the dream of future explorers. Future of space exploration, which is closer than ever. NASA's Artemis mission aims to build a permanent moon base, paving the way for deeper space travel. By the 2030s, we may witness the first crewed mission to Mars, making a historic leap for humanity. Asteroid mining promises new resources, while space tourism brings the cosmos within reach of civilians. Efforts like SETI and the James Webb Space Telescope continue the search for life beyond Earth. Together, these bold missions push the boundaries of science, technology, and human imaginations. The components of the standard atmosphere. The standard atmosphere is a model used in aviation and aerospace to define atmospheric properties at various altitude under average conditions. These properties are essential for designing aircraft and conducting performance calculations. Troposphere. Extend up to 11 km, temperature decreases with its altitude. Stratosphere from 11 km to about 50 km, temperature increases with altitude due to ozone absorption of UV radiation. Mesosphere from 50 km to 85 km, the temperature decreases with its altitude. Thermosphere from 85 km upward, temperature increases significantly with its altitude. Exosphere, the outermost layer, merges into space. The final layer stretches into space and houses the satellites. These are the layers of the atmosphere. We are going to discuss about atmospheric properties and its key elements are pressure density and temperature, which decreases with its altitude about sea level 15 degrees centigrade, and the density of 1.225 kilogram per meter cube and the 1013.25 megapascal. And the properties influence everything from weather patterns to aircraft performance. Understanding the atmosphere is vital for aviation, climate science, and explorations. It's more than air. It's a dynamic system that sustains life and shape our environment. Pressure, temperature, and density altitude. First, pressure. This is simply the weight of the column of air above us. As you climb higher, there is less air above, so pressure decreases. Next, temperature. This is a familiar measure of how hot or cold the air is. Warmer air is less dense and the colder is more dense. Finally, density. This refers to the mass of air per unit volume. Think of it as how thick or thin the air is. It's the most crucial of these parameters for aircraft performance. Density altitude. Pilot must consider density altitude when planning flights, especially in hot weather or at high altitude airports. Performance charts and manuals provide guidance based on density altitude for safer operations. Now, let's talk about density altitude, which is arguably the most important of this concept for pilots. High density altitude, such as hot, high, humid, aircraft struggling to take off or climb, reduced engine power, longer takeoff route, slower climb rate. Low density altitude, which is cold, low, dry, aircraft easily taking off or climbing. For example, it can steep upward arrow. Density altitude is not a physical height, but rather the performance altitude. It's defined as the pressure altitude corrected for any standard, non-standard temperature. Essentially, it's the altitude at which the aircraft feels like it's performing. Impacts on aviation performance. So it depends on takeoff and landing, also the climbing. So higher density altitudes requires longer runways for takeoff and landing due to reduced engine power and lift. Climb rate. Reduced air density at high density altitude decreases the rate of climb. Engine performance. Engine produce less power in less dense air, affecting overall performance. These and all based on the thrust of the aircraft. Thanks for watching.